Jeremy, we're going to go ahead and get started.
Okay.
Okay, hello, and welcome to NOAA's National Ocean Service Science Seminar Series. My name is Tracy Gill. Today, and for all Tuesdays through June 11th, I am co-hosting a seminar series with Gyami Shrestha, Director of the U.S. Carbon Cycle Science Program Office. Gyami will offer information on the background for this series and introduce the seminar and the speaker. But before she does, here are some logistics and related information. The presenter today has 5 clarifying questions during the seminar. Go ahead and type them into the chat box, and he will get to them when he can. If you are interested in getting a PDF copy or recording of today's presentation, we will list the relevant websites in the chat box, as well as links to the SOCCR2 report. Or you can contact me, tracy.gill@noaa.gov, or Gyami Shrestha, and we will be happy to send you a copy. If you are not on NOAA's weekly seminar list that you'd like to be, please email me at tracy.gill@noaa.gov, and I will add you to the list. Folks in the room, please sign in and silence your phone. And now I will hand it over to Gyami Shrestha to introduce the seminar and the speaker. Gyami?
Thank you, Tracy. Hello, I am Gyami Shrestha, Director of the U.S. Carbon Cycle Science Program Office and co-host of this webinar series, today with Tracy Gill from NOAA. Today's seminar is the 10th in a 3-month seminar series titled From Science to Solutions, the State of the Carbon Cycle, which is focused on communicating the second state of the carbon cycle report findings in relation to current and broader societal impacts and solutions. The series is sponsored by the U.S. Carbon Cycle Science Program in partnership with NOAA. For those who don't know about the U.S. Carbon Cycle Science Program, we are an interagency partnership led by the Carbon Cycle Interagency Working Group. We coordinate and facilitate federally funded carbon cycle research with the science community, and we provide leadership to the U.S. Global Change Research Program on carbon cycle science priorities. We are one of the longest-running U.S. interagency partnerships in global change research. Most recently, we led the development of the second state of the carbon cycle report with a diverse team of over 200 U.S. and international experts for over 3 years. This decadal assessment underwent rigorous multi-draft peer review by the U.S. National Academy of Sciences, the public, and 13 federal agencies and departments before its release in late 2018. On the occasion of Earth Day last week, we released a new metadata embedded website for this special carbon assessment. The website is carbon2018.globalchange.gov. Check it out. It's very beautiful and very user-friendly. On behalf of my colleagues, I would like to express our deep gratitude to NOAA and Tracy Gill, as well as all webinar speakers for making this webinar series possible. For your future reference, the recording of prior webinars in this series, the recordings and all the details of the series are available on the YouTube channel of the U.S. Carbon Cycle Science Program. All pertinent slides and details of the webinar series are available on the program website carboncyclescience.us. Today's seminar is titled Global Carbon Budget Accounting Following the State of the Carbon Cycle Report, the Regional Carbon Cycle Assessment and Processes Study, or RECCAP-2. And our speaker is Dr. Ben Poulter. Ben has been serving as a valuable member of many of our interagency and community activities, including the second state of the carbon cycle report assessment process, the North American Carbon Program, and the Global Carbon Project. Here is some more background on Dr. Ben Poulter. Dr. Poulter is a research scientist at NASA Goddard Space Flight Center in the Biospheric Sciences Lab. His research involves using remote sensing and land surface models to understand the role of terrestrial ecosystems in the global carbon cycle. Ongoing research projects include, first, attributing the role of forest age and forest structure to the land carbon sink. 2. Quantifying trends and variability in global wetland methane emissions. And 3. Evaluating climate mitigation strategies and trade-offs on ecosystem services. Ben is the deputy lead for candidate architecture design phases in the NASA Surface Biology and Geology Designated Observable, recommended by NASA 2017 Decadal Survey. Ben received his PhD from Duke University and currently serves on the Scientific Steering Committee of ILEAPS, which is a global research project of Future Earth. He also serves on the Scientific Leadership Group of the North American Carbon Program and the Steering Committee for Regional Carbon Assessment and Processes Study, or RECCAP-2, which he will talk about more. Well, welcome, Ben, and thanks for presenting your work at the NOAA Science Seminar today. Ben?
Okay, thanks so much, Yami. Thanks, Tracy, for hosting the webinar. And thanks, everybody, for spending your lunch or wherever time zone you're coming from with me on the webinar today. So as Yami mentioned, I wanted to take this as an opportunity to talk about the Regional Carbon Cycle Assessment and Processes Study, or RECCAP-2, and kind of put this in the context of the State of the Carbon Cycle report, which relies on several of these syntheses studies like RECCAP and the North American Carbon Program site and regional synthesis activities. So this is a presentation by myself, but with contributions from the RECCAP-2 steering committee, whose names are listed below. Okay, and then I'd also like to acknowledge the participants from our recent kickoff meeting that we had in Gotemba, Japan, about a month ago. You can see here we had about 50 people attend this kickoff meeting, which was supported by ESA, the European Space Agency, and also by NEAS in Japan. Tracy asked for a headshot, but that's the best I'll do for now. So that's me for those of you on the line who I haven't met in person. And the outline of the presentation will kind of begin with an overview of how we got to RECCAP-2, and I'll kind of give some context about why RECCAP-2 has been initiated. Talk about some of the goals that we have for RECCAP-2, which are quite different to RECCAP-1, and we're trying to advance some of the perspective that we can get through this new activity. Go over the RECCAP-2 approach and some of the protocols that were developed at the Gotemba meeting. And then the final slide has some information about how you might be interested in engaging with RECCAP-2. It's an open effort, open to the community, and we're also about to be posting an ad for a postdoctoral scientist to work on the North American chapter for RECCAP-2. So as everyone is familiar with, atmospheric CO2 concentrations continue to increase. And so this is shown by the figure here from the Keeling curve. And I also wanted to kind of bring attention to this figure that Robbie Andrew recently posted on Twitter. And Robbie's been involved with Global Carbon Project activities for some time now, producing really great illustrations. And this is simply showing that we're approaching the annual maxima for CO2 concentrations at Mauna Loa. But then he was kind of superimposed this on the artwork of Hokusai and the Mount Fuji series. So if you're on Twitter, I'd recommend checking out his feed. So the road to RECCAP-2, I wanted to start by revisiting what happened in RECCAP-1, which was the first regional carbon cycle and processes study. RECCAP-1 was coordinated and initiated by the Global Carbon Project and began around 2007 and ended in 2012. The idea was to develop carbon budgets for the time period of 1990 to 2008 using existing model data and observations and providing a new and traceable analyses for developing the different budgets. And the mandate was to establish mean carbon balance of large regions, which I'll discuss in a minute, including land and ocean, to compare the independent top-down and bottom-up budgets to assess uncertainties, and then to evaluate interannual variability trends and the underlying processes. And so you can see that it was quite important that we covered this roughly 2-decade time period to be able to have a sense of what the variability was both at the interannual and decadal scales. RECCAP had split up the land into 10 different regions, which roughly correspond to the continents, but in some cases split into subcontinental regions based according to some biome level similarities. And for the ocean side, there were the four ocean basins were included, splitting the Atlantic and the Arctic into 2 separate regions. And then there were also some kind of special topics, chapters that were introduced, including the coastal zone, a special topic on economic and trade-related flows of carbon, and a couple of other special topics included. And the goal of RECCAP-1, or another goal of RECCAP-1, was to provide these budgets that kind of bridge a Tier 1 and Tier 2 type classification in the language of the UNFCCC, where we could take global products of carbon stocks and carbon fluxes and cookie cut them into the regions that RECCAP-1 was focused on, or we could have regional models that might be calibrated to regional inventories or other data sets that have higher accuracy at the regional level. Just briefly, why did the Global Carbon Project take this responsibility to carry out RECCAP-1? Well, the Global Carbon Project is a global research project now of Future Earth, where Future Earth is a consortium of research activities, research projects that aim to provide information on Earth system scale sustainability. And you can see in the table on the left that there's a list of projects or global research projects, as they're referred to, and the Global Carbon Project is listed under one of these. The Global Carbon Project has been around for some time now, and began with this annual accounting activity of the global carbon budget, which is published roughly in October, November time each year. This year, the global carbon budget will be published, I think, for the 8th or 9th time. About 3 years ago, the Global Carbon Project launched the Global Methane Budget activity, which was published in 2016. And currently, the Global Carbon Project has been working on a nitrous oxide budget, kind of completing the 3 main greenhouse gases. And the N2O budget should be published this summer sometime. The Global Carbon Project also has activities around urbanization, looking at emissions from cities and other kind of sub-regional sources of CO2. And so RECCAP is an extension of some of these activities. And as you'll see in a later slide, RECCAP2 aims to tie together the 3 main greenhouse gases that that the Global Carbon Project has been focusing on recently. So RECCAP-1 took place over this 5-year time period and resulted in a special issue that was published in Biogeosciences. The articles started to become published around I think 2012 and kind of trickled in through 2015. And there's roughly 15 to 20 articles in this special issue. Some of the main findings are that there's net land uptake of carbon across the major biomes. And again, this is in the context of a budget that was done from 1990 to 2008. And so we're seeing a switch in the carbon sink status, particularly in the tropics, which kind of calls or highlights the need for updating this sort of synthesis activity. RECCAP also highlighted the role of lateral fluxes, particularly from riverine systems going from the land to the coast to the ocean, as well as highlighted the role of trade fluxes or lateral fluxes in crops and wood harvest. RECCAP provided estimates of the transfers of carbon and the evasion of carbon from aquatic systems along this continuum. RECCAP also aimed to integrate atmospheric inversions, so what we refer to as the top-down approaches, and ocean biogeochemical models and land biogeochemical models, what we refer to as the bottom-up approaches. RECCAP attempted to develop some new techniques for handling uncertainties, for example, using Bayesian approaches to propagate the errors from the different source and sink terms, or by evaluating how the error covariance structure is different between the top-down and the bottom-up estimates that were provided. And lastly, RECCAP kind of resulted in some recommendations for improving global carbon observing networks. So as I mentioned, the Global Carbon Project has been kind of broadening out beyond CO2, and their global methane budget was published in 2016 by Marielle Sonnois. This is a cartoon showing the major sources and sinks of methane, and an update to the global methane budget, extending the budget from the 2000 to 2012 period, which is published, which is in this image here, and will now be updated to cover the 2000 to 2017 time period, and that should be published later this year. And as mentioned, the nitrous oxide budget has been developed, covering the years 2000 to 2015, and this activity is expected to be published later this summer. So kind of parallel to the RECCAP-1 activities, there's been a lot of activity in terms of international treaties on climate mitigation, and the Paris Agreement and the IPCC special report on 1.5 degrees have kind of recently been signed and also published. And so just to refresh our views on this, the IPCC 1.5 degree report specifies that to avoid or to stay below a 1.5 degree warming requires about a 45% reduction of CO2 emissions by 2030. In the 2 degree context, this would be about a 25% reduction in CO2 emissions by 2030, and then reaching net neutral emissions by 2050 to avoid 1.5 degrees, or 2070s to avoid 2 degrees. And the figure on the right here shows where we are currently in terms of the emission commitments that countries have made, and they fall kind of far beyond what's needed to avoid either 1.5 or 2 degrees warming. The Paris Agreement had a few articles that were relevant to carbon cycle science. So one is this concept of reaching peak emissions and then achieving a balance of anthropogenic greenhouse gas emissions and removals by sinks in the second half of the century. And then Article 14, which specifies the need for a periodic global stocktake of the implementation of the agreement to assess how effective the commitments have been so far. And so, so you can see that there's a high dependency on coming to terms with some of the greenhouse gas budgets and accounting techniques that we have available to be able to address the needs of the Paris Agreement. And then in terms of where we've come in carbon cycle science, I just wanted to highlight a couple of studies that have been published recently. The figure on the left here shows a study by Philippe Sier that shows this emergent relationship of the global carbon cycle, where on the x-axis we have the CO2 emissions from fossil fuels and cement going all the way back to the early 1950s to the present day, and plotting this against the interhemispheric gradient of atmospheric CO2 concentrations between Mauna Loa and the South Pole. And the upper line with the diamond symbols shows the relationship between fossil fuel emissions and the interhemispheric gradient if there was no uptake by the land and ocean of atmospheric CO2. And then the lower line with the circles shows the observed relationship between fossil fuel emissions and the interhemispheric gradient. And so you can see that there is a removal of CO2 by the land and ocean that's proportional to the emissions of fossil fuels and cement. And this paper follows up this emergent relationship using a two-box inversion model to attribute the uptake of CO2 from the atmosphere mainly to the northern hemisphere, and that uptake rate is increasing over the past decade relative to the past 5 decades for reasons that we're not entirely sure of, but could be related to increased nitrogen deposition, climate change in the higher latitudes, and changes in forest management and forest regrowth. Another study published this spring by Nicholas Gruber on the ocean carbon cycle used an extensive network of dissolved CO2 concentrations to model changes in ocean carbon uptake from 1994 to 2007. And based on this data-driven approach, showed that the oceans have also been increasing in terms of the amount of CO2 that's been taken up relative to fossil fuel emissions, and we're able to look at some of the finer scale or kind of basin scale patterns in the uptake of atmospheric CO2 by the ocean. And the two studies combined provide further evidence that the land and ocean carbon sinks have remained proportional to the amount of fossil fuels that have emitted CO2 over the past 5 decades. And so this brings us back to the concept of the airborne fraction, which has remained constant, and questions associated with for how long can the airborne fraction remain constant until the land and ocean sinks remain saturated, or until expected feedbacks related to climate change might kick in. And then in terms of how well we're doing reconciling the top-down and bottom-up budgets, I just wanted to bring us back to the State of the Carbon Cycle report, but also to some of the synthesis activities that were based on RECCAP-1. This work by Jacob Scheisler attempted to take kind of what we considered the best-known bottom-up fluxes of net primary production, heterotrophic respiration, CO2 emissions from fires and wood and crop harvest, and put these together to calculate global net carbon exchange. And when they did this, they came up with an estimate of about 5 petagrams of net carbon exchange, which should be balanced if all the source and sink terms are known completely. And then when this is combined with the fact that there's also an increase in atmospheric CO2 concentrations, this bottom-up approach shows that there's an imbalance of about 10 petagrams of carbon per year. Most of this can be explained by biases in how we treat eddy covariance measurements of CO2 and upscale those estimates. And so you can see that the NEP term here, which is the terrestrial carbon sink, is an order of magnitude larger than what's commonly accepted. So we're looking at something close to a minus 20 petagram sink rather than about a minus 2 petagram sink. But it shows that we still have work to do in terms of trying to put together these component flux terms to close the budget. And then coming back to SOCCR2 from Chapter 2 by Dan Hayes, there's a suggestion that there's a convergence between the top-down and the bottom-up estimates of the North American carbon budget. And so what this figure is showing is from SOCCR1, where we have this fairly wide range of uncertainty coming from the inventory estimates of the North American carbon sink, and how this compares to atmospheric inversion models that were used in the NACP synthesis activity, and how this compares to the inventories also used in NACP activities. And so you can see we've got this large uncertainty and fairly significant systematic differences between the methodologies that are used. And then as we move to the more recent estimates, we can see that those systematic differences are arguably a little bit smaller, and the uncertainties around the different methods have begun to shrink. And so it raises questions about whether our understanding of the carbon cycle is improving, and that's why the uncertainties are becoming reduced, or have we or are we using the same models, the same data? How are the top-down and bottom-up approaches and methods that we're using changing over time? So this brings us to the need for these synthesis activities to continue. And so I want to just highlight some of the goals that we have for RECCAP2. So the charter for RECCAP2 is that it will design and perform a set of global syntheses and regional greenhouse gas budgets of all land and oceans, and explore the mechanisms by which to deliver regular updates of these regional assessments based on scientific evidence, considering uncertainties, understanding of drivers, and retrospective analyses of recent trends. And so RECCAP2 is not only aiming to provide the accounting of the greenhouse gases, but also to try to understand the processes that are responsible for the different source sectors and the different sink sectors. Some of the features for the RECCAP2 activity which distinguish it from RECCAP1 are listed below here. And so the RECCAP2 activity, the aim is for it to take place over the next 3 years, so from 2019 to 2022, and to have the process take a little bit less time than it did for RECCAP1. The goal is for the first set of chapters to cover to come up with a budget for the 2009 to 2018 time period. RECCAP2 again will bridge these Tier 1 and Tier 2 definitions from the UNFCCC for estimating the greenhouse gas fluxes and changes. RECCAP2 will include CO2, methane, and nitrous oxide. The regions are slightly different to RECCAP1. and the special interest hotspots have been expanded to include semi-arid regions and also blue carbon from coastal regions. We've worked quite a bit on developing the accounting framework to be consistent across the regions and to be able to have this framework be based around stock change, but also fluxes. The attention will be paid to quantifying the uncertainties and building off the Bayesian framework that was published by Lee et al. in PNAS a couple of years ago for RECCAP-1. Since RECCAP-1 was completed, there's been some new data sets, which I'll mention, that we'd like to use in RECCAP-2. And then there's some discussion and interest to see how RECCAP-2 can be used to help constrain some of the uncertainties around various climate carbon feedbacks. And lastly, RECCAP-2 and the effort that's going into defining and establishing the protocols will hopefully lead to a framework that can be applied for some sort of semi-regular annual to biannual updates of the greenhouse gas budgets. So just going back to the idea of the new regions and the special interest hotspots, currently 11 land regions have been identified where each region makes up its own chapter or contribution. We have 4 ocean regions, and we have this idea of special interest or hotspots, which include permafrost, semi-arid regions, coastal zone, as well as global synthesis, with the idea for the global synthesis being a summation of the regional budgets or the regional chapters, and then to see how well they compare with global estimates. And there's been quite a bit of discussion on trying to maintain a balance between how the regions are defined based on similarities in terms of climate zones or biomes, but then also being policy relevant, where at the highest level of policy relevance, the budgets would be done at the national level, but then recognizing the effort that would be needed to do these budgets at the national level, and trying to implement some sort of hierarchical approach where we could, for key countries, be able to extract those budgets from the larger regions. So the RECCAP-2 approach then is to have these the top-down and the bottom-up estimates for the greenhouse gas budgets, and these will be based on sort of the traditional data sets of coming from atmospheric inversions and biogeochemical models. But building on the lessons learned from RECCAP-1, we want to pay particular attention to the fluxes that are related to the lateral flows, either from riverine transport or from trade flows. And the framework as it's emerging right now is that we can have a flux-based estimate, so which would be shown by something like net ecosystem exchange for CO2. And the NEE can be estimated from atmospheric inversions or from biogeochemical models that can simulate the difference between MPP and heterotrophic respiration and disturbance fluxes. From an inversion point of view, we can get the CO2. We can also get the carbon from carbon monoxide inversions and from methane inversions, and then use biogeochemical models to get the VOC losses of carbon to the atmosphere. Or we can use stock change approaches, where we can use models or inventory or national reporting of stock changes of biomass, soil carbon, and then add in additional stock change estimates coming from the riverine and the coastal processes, and the trade flows, as well as including the emissions from fossil fuel activities. And the idea is that the flux-based approach or the stock change approach should ideally agree with one another if all of the component fluxes have been accounted for correctly. The examples of the data sets that we intend to use, again, come from atmospheric inversions, biogeochemical models, either from dynamic global vegetation models on the kind of the prognostic end of the spectrum, to satellite-based approaches that might rely on upscaling of eddy covariance data, or things like MODIS, MPP. We also will be using the inventories and taking advantage of the different inventories to get a sense of what the uncertainties are, and then also using various greenhouse gas observing networks, either to look at the mass balance changes of the greenhouse gases in the atmosphere, or for initializing the atmospheric conversions. And then on the stock change approaches, we hope to take advantage of some of the emerging data sets for above ground biomass that now exist at the global scale. So these are things like some of the LIDAR-based work that is coming out of Woods Hole or JPL, some of the microwave-based work like this blob biomass product from ESA, and then some of the L-band microwave-based data on the vegetation optical depth, which is related to biomass. And then link this with land use and land cover change mapping, and then also address the soil carbon stock changes through data where available, but most likely relying on models to estimate soil carbon stock changes. As mentioned, we have, I think, some novel data sets to consider in doing the budgets. So there's this the VOD, the vegetation optical depth, L-band microwave data that's related to biomass, and we have multi-year time series of VOD, so we can look at the biomass stock changes and relate these to fluxes. On the methane side, there's an activity to develop an upscaled wetland methane emissions data set by linking together a global network of eddy covariance and flux towers, and applying some sort of data-driven upscaling approach to those. There's new data on the spatial distributions of ocean CO2 changes, and then and kind of the increasing constellation of greenhouse gas satellites like GOSAT, OCO2, and I think OCO3 was launched this morning. And then the kind of the last component of RECCAP2 is related to how the budgets will be communicated more broadly. There's kind of this trade-off between having simple budgets that are easy to present to various stakeholders, including policymakers and scientific audiences. And so here's a figure by Hanshin Tian's work looking at a multi-greenhouse gas assessment of fluxes from the land to the atmosphere. But then you can have even more kind of complex ways to illustrate these sources and sinks, accounting for multiple greenhouse gases, but you start to lose a little bit of the transparency at this scale. And so to RECCAP2, I think some of the main take-home points are that it will be carried out as a multi-greenhouse gas assessment for the period 2009 to 2018. The chapters so far will encompass 11 land regions, the 4 ocean basins, and around 3 to 5 special interest themes that include permafrost, blue carbon, and semi-arid regions. We're developing a consistent workflow to be able to equate the stock change approaches with flux-based approaches to assess the sink source status of each region. We'll kind of continue to build out on the use of bottom-up and top-down approaches to assess the uncertainties and identify research gaps. And then build a framework for sort of a semi-regular greenhouse gas budgeting within the context of some of the international climate mitigation treaties that are out there, mainly the Paris Agreement, and how the role of greenhouse gas budgets are required for things like Article 4 and Article 14. So, to engage with RECCAP-2, the kickoff meeting we had in Japan was to mainly identify regional leads, either for the land or the ocean component. And now those folks are over the next couple of months building out the regional teams to develop the budgets. And so it's an open process, and we're keen to have people become engaged if they're interested in working with the RECCAP2 group. So this slide has a few links of how to do that. So there's a link here on a summary of RECCAP1 and a kind of a growing web page on the RECCAP2. This is also a plug for an upcoming AGU Chapman conference on carbon climate feedbacks that will be in San Diego the last week of August. And the abstract submission deadline is May 8th. And we're hoping to have some sort of breakout group at the Chapman conference to discuss RECCAP2. There's also postdoctoral scientist position that will be recruited through the Mendenhall Fellowship Program and based out of USGS in Menlo Park with Lisa Marie Wyndham-Myers, and co-supervised with Anna McCulloch at Carnegie and myself. And the position for this scientist is to kind of focus the effort on the North American greenhouse gas budget, but then to also bridge that work with some of the riverine fluxes of carbon from and tying together some of the ideas from the land to coastal to ocean interfaces that we feel are important for reconciling the top-down and bottom-up approaches. And then lastly, for kind of the main contacts of myself, Pep Canadell, and Rob Jackson. And so please, yeah, contact me if you're interested or have questions about where RECCAP2 is going. So with that, I think there's time for questions or discussion. Yeah.
Great, thanks, Ben. Folks online, if you have a question, go ahead and type it into the chat. Then while people are thinking about their questions, I was really interested in hearing about communicating to policymakers. Was that a big effort in RECCAP1, or how do they plan to do that in RECCAP2? Or is that not your bailiwick?
When RECCAP1 was taking place, you know, the Paris Agreement had yet to be signed, and there was obvious interest in the policy level in the greenhouse gas budgeting, but no sort of mandate. And so with this Article 4 on countries becoming carbon neutral or greenhouse gas neutral, there's really a call on the scientists to be able to provide the data and the observations that are needed to help the countries make those reports. So I think RECCAP2 is in a, yeah, I think some of the global carbon budget, global methane budget, N2O budget have sort of the right frameworks to be able to do these assessments, and RECCAP2 helps kind of aims to downscale that to the regions or to even the national levels that are needed to provide the reporting.
Okay. Well, thanks. Other questions online, folks? You can type your question into the chat box. I have one more question, Ben. This is Tracy again. I just wanted to, do you think the Paris 2 agreement, I'm sure people fought to make it more aggressive, but do you think it's aggressive enough, or could they have done more, or that was the best they can do balancing all the different realities that we have?
Well, I was going to just go back to the slide on Paris. Around here, I think, yeah. I mean, so these emission pathways are built around the concept of the remaining carbon budget, where if you want to avoid some sort of temperature change, how much CO2 or CO2 equivalents can be emitted until you exceed that temperature threshold, and these are typically done with something like, let's say, like 50–60% confidence that you will avoid that temperature change, and so there is a bit of an envelope around whether or not the emission pathway will avoid that temperature change. So I think that kind of answers the question a little bit in terms of saying, well, yeah, that buffer is in the pathway, and a 45% reduction of CO2 emissions by 2030 seems quite ambitious, and I think that this is why there's also these 5-year commitment periods where the global stock take starts to play a role, where every 5 years we kind of take a step back and look at how well the emission reduction commitments are being met, and what does that mean for the pathway that we're on. So I think twofold, that there is kind of a buffer in these emission pathways, and then these like 5-year stock takes should provide some time in being able to respond appropriately if the pathways, if we're not on track relative to that pathway that's needed.
Okay. Yeah, that helps a little bit. Thank you. Looks like Gianna has a question. Could you say a bit more about your experience at the first RECCAP2 conference in Gotemba in terms of the international collaborations already happening and those happening in the near future?
Right. So RECCAP2 was able to secure funding from the European Space Agency, and who are keen to see how the products that have been developed through their climate change initiative can be relevant for a whole variety of scientific purposes, but obviously in this case for informing greenhouse gas budgets and accounting. And so ESA is supporting several activities at University of Exeter, the Max Planck Institute, and at the LSCE in France, and so that's been going on for maybe the past year or so. So there's quite a bit of activity in Europe. We had participants to then kind of build out on that from Brazil, Japan, Australia, New Zealand, China, and Russia involved. And so I'd say it was maybe kind of half of the people that were there were involved with the first RECCAP activity, but there's a strong push to getting a new generation of scientists involved with RECCAP2. And so trying to kind of balance the experience and expertise that was developed in RECCAP1 with bringing in new people to keep RECCAP2 going into the future.
Okay.
I think on the U.S. side, we're hoping to leverage the work that's coming out of the carbon monitoring system that's supported by NASA, and looking at how those products can be useful for either the Tier 1 or Tier 2 type budgets that RECCAP2 will develop.
Okay. Any other questions? Comments? Thank you so much, Ben, for a terrific presentation. Folks, if you're interested in getting a copy of these, you can email Gianni or myself, and we'll be able to send you a link to the recording or the PDF. And next week, on Tuesday, May 7th, we'll have an overview of global carbon cycle. Where are the gaps in our understanding? By Lori Bruweiler, physical scientist at NOAA OIR Esrael, Global Monitoring Division. So I hope you can join us. Thanks again, Ben. Any last words?
No, thank you. And I hope that I hear from folks, offline, and as people's interest increases. So so please get in touch if you have questions or are interested in being involved.
Okay, well, thanks.
Right.
Thanks, everybody, for joining us. Thanks, Kiyomi. Bye-bye.